I'm going to make a few general comments about some commonly known rings that we're going to use throughout this chapter and the next few chapters. And so those are the real numbers, the complex numbers, the rational numbers, and then, of course, the integers. So we are going to assume that those are rings under the usual addition and multiplication the way we know it. And the real numbers we're very comfortable with, the integers we are very comfortable with, the rational numbers, Q, those are all numbers of quotients of integers, so A over B, where A and B are integers and B can't be 0. So those are our rational numbers. And then our complex numbers are all numbers of the form where we have a real number plus another real number times the square root of minus 1. So a plus bi, where a and b are reals, and then I, of course, is the square root of minus 1. So those are complex numbers. And complex numbers, we can add them, we can multiply them, and so the way we add complex numbers, just a little crash course. So I'm going to take a little space right here. So if we're looking at our set of complex numbers, if you have a number a plus bi and another number c plus di, and so we have two complex numbers right here, then how do you add them? Well, a plus bi plus c plus di is equal to, we are doing this component-wise, so we are adding the real parts, a plus b, and we are adding the complex parts, the imaginary parts. So that's b plus di. So as an example, if we have 1 plus 2i, and we are adding 0.7 minus 3i, then that is 1.7. So I added the real parts, and then I have 2 minus 3, that's a total of minus 1i. So that's minus 1i. We can also multiply complex numbers. So again, we are starting with a plus bi times c plus di, and what is that? You can distribute. So think of these just the way that you would distribute polynomials. You can do that right here as well. So we have a times c, then we have a times di, and then we have bi times c, and then we have bi times di. And this we can do stuff with that. So this is AC plus ADI plus BIC. B and C are real numbers. I is our square root of minus 1. I can write that as BC times I. And then BI times DI, what is that? That is B times D times I squared. But remember that I is the square root of minus 1, and so when you're taking I and you're squaring it, you are taking the square root of minus 1 and we are squaring it, and that is minus 1. So this becomes AC plus ADI plus BCI, and then minus BD. And so here we can see we have two real pieces, and then we have two imaginary pieces, and I can collect those. So this is AC minus BD, that is my real part, and then I can factor out that I, and I have AD plus BC times I, and so this is another complex number, because this is a real number, AC minus BD is a real number, and then AD plus BC, that's a real number. So you can see we've written the product of our two complex numbers again as in the form of a complex number. So that's how you add and multiply complex numbers. So if we wanted to see our example from before, so what is 1 plus 2i times 0.7 minus 3i? I don't know if I'm going to get that right. So we have 1 times 0.7, that's 0.7. And then we have minus 3i. We have plus 1.4i. And then we have minus, nope, we have, well, let's write it out. We have 2i times minus 3i. So what is this? 0.7 and then minus 1.6i. And then 2 times minus 3, that's minus 6. But I squared is also minus 1, so that's a total of plus 6. Right? Because I have minus 6 times I squared, which is minus 6 times minus 1, which is a total of plus 6. So I can do a little bit of cleanup. What do I have? I have 6.7 minus 1.6i. I hope I did all the arithmetic right. But so we see again that this is a complex number. We've written it in the form of a complex number. So that's how addition and multiplication of complex numbers works. Now going back to my box right here, we also, for a general ring R, we're using the following standard notation. So M sub n of R is going to be the set of all n by n matrices with entries in R. So we already saw that when we looked at sets of matrices as examples of rings. So now R is just tells us that the entries in our matrices come from a ring. And then the set R adjoint X, that's how we say that, R with those in bracket X, is a set of polynomials in X with coefficients in the ring R. So polynomials, the way we know it, we have a constant term, we have a linear term, constant, linear, quadratic, and so on, up to x to the n. So, and then the coefficients, a0, a1, a2, up through an, they come from our ring. So they are elements in our ring. So this is notation that we are going to use throughout the exercises and for examples